So this video will be explaining the electron transformation in the ionic bound using diagrams. And the diagrams are Bohr-Rutherford diagram and the Lewis diagrams. We have 4 examples in total, and there are 2 Bohr-Rutherford diagrams and 2 Lewis diagrams. So let's start with the first example. Beryllium and oxygen. So we need to separate the transformation of electrons into 4 steps, which the first step is to using the crossing method to cross the valencies of each element. So the valency of beryllium is positive 2, while the valency of oxygen is negative 2. So they are the same, and we cannot use Be2 and O2 because it's repetitive. So we can simply apply BeO, which is beryllium oxide. And step 2 is to draw the Bohr-Rutherford diagrams, which the teacher is required to use. And the outer shell of beryllium, there's 2 electrons, and for oxygen there's 6, which it needs to gain 2, while beryllium needs to lose 2. So by adding the 2 extra electrons from beryllium on the losing electrons on oxygen, we can get a full diagrams. And that's step 2 and 3. I didn't separate them quite clear, so let's go straight into step 4, which is the ionic Bohr-Rutherford diagram. And we can see that the outer shell of beryllium is totally eliminated. There's only 1 shells. And the valency now is 2+. It's positive 2 because it loses 2 electrons, while oxygen is 2 minus negative 2 because it gains 2 electrons. That's the first example. Let's go to the next example, which is magnesium and chlorine. So magnesium, the valency of magnesium is positive 2 because it's a metal, so it's positive, and it loses 2 electrons, while chlorine has a valency of negative 1. Well, by also using the crossing method, we can gain the compound which MgCl2, which is magnesium chloride. And this example, we need to apply Lewis diagram, which also is required. So by drawing the Lewis diagram, we only need to draw the outer shell electrons, which Mg has 2 and each Cl has 7, which Mg needs to lose 2 while Cl has to gain 1 each. And those arrows is the directions that the electron goes, which goes from magnesium to chlorine. And the final step is also the ionic Lewis diagram, which we can see that the outer shell of magnesium is also removed, and it has a valency of positive 2 because it loses 2 electrons, while each chlorine has a full outer shell, which is 8 because it gains 1, so the valency is negative 1. The next ionic compound is lithium and sulfur. So lithium has a valency of positive 1, while sulfur has negative 2. And by applying cross method, we can gain result of 2 lithium and 1 sulfur, because we need to balance the amount of positive and negative charges in order to make the compound neutral. So the final product is lithium sulfide, and for this explanation, we are required to use Bohr-Rutherford diagram, which lithium has 1 outer shell electrons each, and there's 2 lithium total, and sulfur we need there's 6 outer shell electrons, which we need to gain 2 in order to have 8, like the full outer shell the full amount of outer shell electrons. So the final step is to draw an ionic Bell-Rutherford diagram, which lithium has lose its one outer shell electron, which it only has its inner shell, and so it loses one, so the valency of it is positive 1. While sulfur gains 2 from each lithium. Oh no, it gains 2 electrons in total and gains 1 from each lithium. So the total valency of it is -2, which it has an 8 electrons outer shell, which is the full outer shell. And finally, let's take a look at the last example, which is calcium and nitrogen. Yeah. Calcium is a metal which has +2 valency, and nitrogen, well, this is actually a little bit weird because nitrogen don't usually shows -3. It usually shows positive, but in some, like in H3, it shows +3, and in this example, maybe it also shows. So by simply applying the cross method, we can gain that there's 3 calcium and 2 nitrogen in each compound. So the final product is calcium nitride. Yeah. The second and third step is using the Lewis diagram, which each calcium has 2 outer shell electrons on its outer shell, while nitrogen has 7. Nitrogen has 5 each, so it needs to gain 3. So each calcium, so the first and the third calcium that you can see right here, each gives 2 to both nitrogen, and the one in the middle, it gives 1 each. So totally, nitrogen is 6 and calcium gave 6, which they're in a equilibrium, which they're in a balance. And the final step is to draw the ionic Lewis diagram, which the calcium loses their outer shell electrons, and it shows a valency of +2, while nitrogen, they gain 3 each, so they show a valency of -3. And I think that's the full explanation about the electron transformation in an ionic compound. And by the way, an ionic bond is the bond between metals and nonmetals, so it's more easier for transforming the electrons because one of them may be positive and one of them may be negative. So it's usually a strong bond, and it forms big lattice, such as NaCl that we know it's sodium chloride, the salt, and it forms big lattice, and it's a strong bond which has higher electron attractions. Yeah, so it's strong. And that's all about this video. Thanks for watching. See you next video.